Every moment, something is in motion. The wind brushing through the trees, cars gliding down the highway, the moon circling the earth. But have you ever stopped to wonder? Why do things move the way they do? Why does a ball stop rolling? Why does a rocket rise against gravity? The answers come from one man's mind. Sir Isaac Newton, a genius who lived over 300 years ago. His 3 laws of motion became the foundation of classical physics, the language that explains nearly every movement in the universe. Today, let's uncover the power and beauty behind these laws and see how they shape everything, from falling apples to flying rockets. Newton's first law is called the law of inertia, and it might be the most relatable. It states that an object at rest stays at rest, and an object in motion continues moving in the same direction at the same speed, unless acted upon by an external force. That means if no force changes an object's motion, it will simply keep doing what it's doing. Think of a football lying on a field. It won't move until you kick it. And when it rolls across smooth ice, it keeps gliding because there's almost no friction to slow it down. In space, where there's no air or friction at all, objects drift endlessly, forever, unless another force pushes or pulls them. Inertia is the universe's way of saying, I'll keep doing what I'm doing, unless you make me stop. The second law is where math meets motion. Newton realized that motion depends on 2 things: how heavy an object is, and how hard you push it. His formula, F(S)mxa, means force equals mass times acceleration. If you apply the same push to a light object and a heavy one, the lighter one moves faster. Try pushing an empty shopping cart. It moves quickly, but if it's full of groceries, you'll need much more effort to make it move the same way. This law is everywhere, in sports, in cars, in rockets. When a sprinter explodes off the starting line, or when a car accelerates after a green light, you're watching Newton's second law in action. Engineers use it to design engines, bridges, and even the thrust of spacecraft. It's the law that connects power with movement, the invisible math behind every push and pull. Newton's third law is elegant and powerful. For every action, there is an equal and opposite reaction. You see it everywhere. When a swimmer pushes the water backward, the water pushes them forward. When a bird flaps its wings downward, the air pushes it upward. Rockets work on this very principle. By blasting hot gases down, they propel themselves up into space. Even the smallest things obey it. When you throw a ball forward, your hand feels a backward push. When you jump off a boat, the boat drifts backward as you leap forward. Newton's third law reminds us that every motion is part of a pair. Every push creates another push in return. It's nature's balance, motion in harmony.